Hello, my name is Sekiyama, Division of Materials Physics, Graduate School of Engineering Science, Osaka University, Japan. In this movie, I would like to show that light is quantized by considering the energy of electromagnetic wave in vacuum and that the minimum energy of the light with angular frequency omega is obtained as h bar omega. Further, I show the Hamiltonian of the electron in the quantized electromagnetic fields, namely photons, where the interaction terms are represented. I hope that the audience has already learned the semi-classical theory of the electron under the classical electromagnetic waves explained in the movie entitled as Lagrangian and Hamiltonian in electromagnetic field, shown here. Please enjoy this movie. I start the explanation of the quantization of light. Here we consider the linearly polarized plane wave light, okay? And electric field E should be real number. Therefore, here we consider the plane wave of this one and its conjugate. Here this bold small e stands for the unit vector indicating the field direction, electric field direction, and k stands for the wave number or wave vector. Here this is a plane wave, E dot k is 0. E tilde stands for the complex amplitude of the electric field. This star stands for the conjugate. In this case, the amplitude of the electric field is given by the absolute value of the complex amplitude of electric field. Then we suppose that plane wave light is given by this electric field. Then the vector potential must be expressed like this one. So this is obtained from the definition of the electric field. Once the vector potential is given, we need to express the light by using the vector potential, because once we get the vector potential, the electric field and magnetic field are automatically obtained. The Hamiltonian of an electron is expressed by using the vector potential. Then we defined small qk tilde as this quantity and its conjugate. Here the large V stands for the volume of the space. Then we can rewrite the vector potential as a rather simple form like this. Then the electric field is given by this one. This is the same as this one. And further, the magnetic field is obtained according to the calculation of this one. Then we consider the energy of the plane wave light in vacuum. So that energy is defined as large E photon. According to the electromagnetism, energy of the electromagnetic field is given by this formula. So this is in the vacuum. We can easily rewrite this formula like this one. Here we see the self-product of electric field and magnetic field. We put this one and this one into here, but we pay attention that the integral of this exponential over the space becomes 0. Therefore, only the cross term contribute to the energy. Then we get this result. Here, this one is equivalent to 1 over mu 0. Okay? Anyway, we get the energy of the electromagnetic field is like this one. And further, we can calculate. Then we get result. Then further, we define the so-called generalized coordinate as large qk, like this one. You can notice that large qk is a real number. Importance is this time-dependent exponential term is added. When we define this quantity, we can get the time derivative qk dot as this one, because small qk tilde and its conjugate are time independent. So then this quantity is expressed by using the large qk and large qk dot, and its conjugate is also expressed like this one. Then we go back to the energy of the electromagnetic field. In the previous slide, I showed the electromagnetic field energy is expressed by using this one. Then we put the exponential term here and here. We put this one by this one, and this term is replaced by this one. Then we get this result. And by the further calculation, energy of the electromagnetic field is also expressed by using the sum of these two terms from this one. Okay? And when we see this result, we can understand that the form is quite similar to the kind of the harmonic oscillator. When we regard the epsilon 0 as a mass, this is equivalent to the harmonic oscillator of the mass of epsilon 0. We can quantize the energy of the light by the same manner of that of the harmonic oscillator. Now, this large P stands for the so-called the canonical momentum, but we need to pay attention that this is not equal to the photon momentum itself. Okay? Then we start quantization of this energy as this one, the same manner as the usual one. Then we calculate this energy, but calculate this term. Then we introduced annihilation and creation operator of photon ak and ak dagger defined by using the canonical coordinate large qk and canonical momentum large pk, this one. We need to express the large qk by using the annihilation and creation operators of photon ak and ak dagger. Then we can understand that qk is expressed by using the ak and ak dagger after the simple calculation. Then we can calculate this quantity by using the annihilation and creation operators. So because this quantity can also be expressed by using large qk and large pk. Since large qk is a linear combination of the ak dagger and ak, and also the pk is given by the linear combination of the ak dagger and ak, like this one, we obtained this result, and finally this quantity is proportional to the creation operator ak dagger. By the same manner, we can also calculate small qk tilde times exponential function of minus I omega t. Then I skipped detail, but finally we get this quantity is proportional to the annihilation operator ak. Then when we remind the energy of the electromagnetic field can be expressed like this one, and we replace this one and this one by these results. Then we get this one, and finally the energy of electromagnetic field is expressed by using h bar omega times ak dagger ak. Then we can quantize light by using the concept of photon with the annihilation and creation operators, like this one. So this is Hamiltonian of photon, and the same manner of the harmonic oscillators, ak dagger times ak stand for the so-called number operator. Since vector potential, classical vector potential is originally given by this formula, then we replace this part and this part by using this one and this one. Then we get the quantized vector potential, quantized light, is expressed by using this formula in the so-called time-independent Schrödinger equation. Here, the explicit time-dependent term is deleted after the quantization of light. Exponential term of I omega t is replaced by the creation and annihilation operators in the Schrödinger representation. The Hamiltonian of the electron with electromagnetic field is expressed like this one. The first term standing for the photon field. After the light is quantized, the incident light is no longer external field. We need to consider both electron and photon field in total. And this one stands for the electron Hamiltonian, and this one is photon field. This Hamiltonian is not mutually interact. So the interaction part is given by the second and third term. So this is the electron-photon interactions term. Third term proportional to the A square represent two photon process because the quantized vector potential is expressed by the linear combination of the A and A dagger. That means the square of A represented by the A dagger, AA, and A dagger, A dagger. So this is called the two photon process. And second term stands for the one photon process. This is a photoabsorption or emission process. In the spectroscopy, dominant term is the second term. On the other hand, for the diffraction, the third term is important. For the spectroscopy, in most cases, the third term two photon process term is seen in the higher order photon process.